Eventually in this video I want to introduce associations, but first I want to give you an idea of what sort of problem associations try to solve. Here I've written two variables or two functions, say that these would be examples of functions that don't have any input, and rs. So I use delayed assignment, that's why it's able to have different outputs when I evaluate it multiple times. It's supposed to give me a random student name or student code. RG is supposed to give me a random course grade. And let's imagine we have a table containing a bunch of data corresponding to student and course grade. So let me make that using table, and it's going to be a list of lists. And the first entry in each inside list is going to be the student. The second entry is going to be the grade. And let's just put 10 of those into a list. And let's call it my list. So a very reasonable question to ask would be, given a student like this student 783, how can I determine that their grade was F? Well, here's one way to do it, and we'll see later that associations provide a more efficient way to do this. So here's the only way I can think of, or like every way I can think of is based on this idea. So it's first figure out what is the pair containing this student. So let me copy that student, and let me say cases inside of my list of all those pairs such that the first entry in the pair is equal to that student. And something's gone wrong because this is in blue. What went wrong? Well, this isn't a string the way I've pasted it in. So I'm going to make it a string by putting in quotation marks. So that's pretty good. And I want to find this course grade of F. So how can I do that? Okay, can I just do double brackets 2? No, I can't. And why not? Well, notice that this output isn't a length 2 list. It's actually a length 1 list. And what's the one element inside that length 1 list? It's a length 2 list. So why is that? Well, cases always returns a list, and it's a list of all the different matches from the original. So here there was just one match. So in this case, cases produces a length 1 list. And the only element in it is that match here. So this is definitely a little cumbersome. How can we make it less cumbersome? Well, here's one way, is instead of having a list of pairs like this, okay, so let me copy this. So actually, let me do it slightly differently from what I was originally thinking. So let me use the second type of iterator, and let me say for every x inside of my list, hey, this, instead of being a list of lists, this is going to be a list of rules. So we're working our way towards associations, but we're not there yet. So this is what's called a list of rules. And then if I want to know what was this student's grade, I can get it much more efficiently using this list of rules together with replacement. So this front slash dot or front slash period, that stands for replace this value according to wherever it shows up on the left side of an arrow in the list of rules. So there was a much more efficient way to get this value of F. And what's another way? So here finally is an association. So first I'm going to convert this list of rules into an association just by wrapping it with this association head. And let me name this my association. And I could do the same sort of thing, like my assoc. Or here's another way I can do it. I can do my assoc brackets, then the student. Okay, that would not have worked with my rules. Let's check. Okay, so it just gave me the same list of rules and then this bracket student. So it really didn't do anything here, but it worked exactly like how I wanted for the my association. Let me give an example of a difference between a list of rules and an association other than this evaluation part. what if for the numbers showing up in these random students, what if I restrict it much more? So instead of going from 0 to 1,000,000 for a random integer, let's just go from 0 to 10. So I've reevaluated that up here. And let's make a new MyList. And so the thing I wanted to check was that some student showed up twice. So notice student 5 shows up twice here, once with an F and once with an A. And so let's make this my rules list. And let's make this my association list. And so one difference is notice that student 5 shows up twice in the my rules list, whereas student 5 only shows up once in the my association list. And these things that show up on the left side of the arrows or on the tail end of the arrows, these are what are called keys in an association. So I can do keys my assoc. And if I want to know how long it is, so there are 7 different students showing up in this list. Whereas if I were to check what's the length of my rules, okay, that's length 10, so nothing gets deleted. Whereas here, duplicate keys get deleted. Duplicate values don't get deleted. So the thing on the right side of the arrow or at the head end of the arrow, these are called values, and those definitely can have repetitions, just like how you would want different students to be able to have the same letter grade. So I can get access to that by doing values of my assoc. And here are the different values listed in the same order. And so one of the big advantages of associations over lists of rules is that you can search for entries in associations very efficiently. So if it's a gigantic length association here, you can still look up what is the value corresponding to a key very efficiently. And if you've studied Python before and you know Python dictionaries, associations are the Mathematica analog of Python dictionaries.